Okay, so the topics today will be basic EIGRP covering the adjacencies, hellos, how they become neighbors. In EIGRP, they're called adjacencies. We'll take a look at the metrics. We'll take a look at the timers. We'll see how easy it is to set up the real basic EIGRP. That's with the network all zeros command. So under 90% of the circumstances, 3 lines of EIGRP configuration will work. It's kind of like the automatic button on a digital camera. For most situations it works, but then for tuning for special situations you want to know how to change the defaults. So start off on router 1. Just make sure your interfaces are set correctly, so show IP interface brief. And as you can see, my stuff isn't set up correctly. So setting up EIGRP, very simple. We could set up our whole network with 3 lines on each router. And if you remember from your OSPF, you'll know that starting OSPF was really simple. It was just the term router. And when you type in the question mark, you get all the different protocols. BGP, EIGRP, ISIS, RIP, OSPF. If you're missing some of these protocols, that means you do not have the EMI image if you're using switches, or you haven't paid for the advanced enterprise iOS. You're probably still running the basic one. I think it's called basic IP or something. So all of you should be running 12, if you show version, 12.4T as recommended in our FAQ. So in my case here, 12.4.15 T14. Okay, so router, EIGRP. We have our AS number. Now, unlike OSPF, where it has a process ID, process ID doesn't have to match in OSPF. So on one router, you could do router OSPF 1. On another one, you could do router OSPF 2. Doesn't really matter. In EIGRP, it does matter. And actually, in CCNA, some of your troubleshooting will be as simple as having a different autonomous system number. And we're actually going to see that today. We're going to set router 1 with an AS of 1 and router 2 with an AS of 2 just to see what happens. So router 1, router EIGRP 1. We'll do the no auto command that turns off auto summarization. And what that does is the router will like to squeeze down all your networks into a classful summary. So something like 10.1, 10.2, 10.3, so on and so forth. It will like to squeeze it down to 10.something/8. So by typing in no auto, we're turning that off. Now I believe in the Nexus that this is automatic. I believe it does no auto automatically. Then our next line is throwing our interfaces into EIGRP. And to do that, we're defining a bunch of network addresses, and the IP addresses that match that range will have EIGRP started. So we have a Hail Mary command. It's 0000. It basically says any IP address. So if I do this, it's going to throw in the fast Ethernets 00 and 01 and the loopback address. And we'll end out of there. So the first command you should do after turning on EIGRP, or one of the first commands, show IP EIGRP interfaces, just to see which interfaces have EIGRP started. So that looks pretty good. We could start a debug if you want. Let's see, debug EIGRP Let's do packets. And you can see about every 5 seconds we're sending some hellos out. Where now it says receiving hellos on the loopback. There's nothing actually attached to a loopback. It's just a fake interface, but it make believes. And this just shows us that we're sending out EIGRP hellos. Right. I'll do a U-all to stop that. Now you'll still have some lingering stuff in the buffer, but that's no big deal. Now let's go over to R2. If you don't have your IP addresses set, go ahead and set them really quick. Okay, we got our IP addresses there. You can just do a quick gut check, ping all 255s. You should at least get to the next side. Okay, so I have a response from router 1. That's good. I don't have a response from router 3 yet. That's because I don't have IPs on router 3. So the process on router 2 is going to be very similar. Now we could do router EIGRP 1, and we know that works, but I just want to show you what happens when you have things in the wrong AS. So we're going to do router EIGRP 2. Going to do the no auto, and we're going to throw all of our interfaces into EIGRP. And out of there, and if you show IP EIGRP interface, you'll see that EIGRP is running. We don't have anything saying neighbors coming up. You could show IP EIGRP neighbor. Nothing comes up. Another verification you probably want to do is show IP protocols. And this will say you're running EIGRP 2. Other side is running EIGRP 1. And we could do a debug. Debug EIGRP packets. So we're sending hellos. Right, so you can see we're sending hellos, but we're still not getting any information or getting an adjacency coming from the other side. So now let's see what happens if we change it. So instead of router EIGRP 2, we change it to the correct one, which is router EIGRP 1. So first we'll take out router EIGRP 2. Very simple. No router EIGRP 2. Now we'll do router EIGRP 1. No auto. And network all zeros to throw all of our interfaces into EIGRP. And we see we get a line saying neighbor 10.10.12.1 is up, new adjacency. So with WebEx, we don't actually see everyone's desktop, unlike Google Hangouts. So if you're feeling like you're falling behind, or if you have a question, click on that chat window and always feel free to type something in. Any problems so far? Is everyone able to get a neighbor 10.10.12.1 coming up from R2's perspective? Okay, looks good. So we have a neighbor between router 1 and router 2. Let's go back on router 1. If we show IP EIGRP Topology, so you can shorten that with TOPO, topo, you'll see that we have the link between router 1 and 2, so 10.10.12.0. You see it's being popped into EIGRP as a /24, which is the same as the mask that we've put on the interface. Successor, we have one way of getting there. FD, this is the feasible distance. This is how much it costs us to get to that link, 281,600. Now EIGRP by default is going to use a complicated mathematical formula that takes into account by default the bandwidth and delay. So it takes the bandwidth and delay and crunches it down to get this number. And they usually tend to be pretty big numbers. It's not like RIP where it's like the hop count, 1, 2, 3, 4, etc. Now we see our link going to router 3. It's the same feasible distance, 281,600. And why do you think it's the same feasible distance? And you can type the answer in the chat window. What's the same here between those two links? So it's not the same path. If we take a look here, from router 1 to router 2 is this link right here. The cost for router 1 to get on this link is 281,600. Router 1 to get to this link, 10.10.13.x, is also 281,600. Well, let's take a look. Let's go on router 1. Show interface fast 00, and you'll see the bandwidth and delay right here. Now if your number is lower than 281,600, you probably have this interface set at 100 megs, because in my case right here, my interface is half duplex at 10 megs. This is a GNS3 thing. We're going to change that in a couple seconds. And my delay is 1,000 microseconds. Now if I show interface fast 01, you'll see that my numbers are exactly the same. So because the bandwidth is the same and the delay is the same, the metric will be the same. But we're going to change that. Let's go to router 3 and make sure your IP addresses and everything are set up. I'm getting too used to, we just got a Nexus 5000, and in there you don't have to do the show command. You just type in the commands like normal. It's very nice, but you get used to it. Okay, router 3 set up correctly. We're going to fire EIGRP up on router 3. And it's going to be the simple Hail Mary command with network all zeros. You can see right here I'm doing that ping all 255s. So router EIGRP 1, no auto, network, all zeros. I'll have two neighbors come up, router 1 and router 2. So here's what we're going to do. We got two links on router 1, one towards router 2 and one towards router 3. Currently, my top link is set at 10 megs. So actually both are set to 10 megs. If I go to the link between router 1 and 3, and I change this to 100 megs, what do you think is going to happen to that metric? Will it stay the same or will it change? Should change because EIGRP by default is using bandwidth and delay. In this case, we're changing delay. So here's how we're going to do it. Let's go on R3 side first. Go on that interface, fast 01, speed 100, duplex full. And you're going to have to do this on both sides. So R1, so you've changed this interface to 100 megs, and you can just verify, show interface fast 01, and you're looking for this line. Let's see here, it's still at 100. There you go. Took a while. So now it's full duplex, 100 megabits a second. Now let's take a look at show IP EIGRP topology. Oh, looks like I don't have my other side set correctly. Okay, show CDP neighbor is usually a very, very good command. So I'm just verifying that I'm on the right interface heading towards R1. So it's fast 01 and fast 01. Show interface fast 01. Now you have a couple interesting things here. Because of that speed command, it's set at 100 megabits a second, full duplex, so that's not a problem. Up here, you'll see that it's still seeing it as 10 megs a second according to the computation. So this is where I'm seeing, if I show IP EIGRP topology, right? Even though I've made the bottom link 100 megs, it's still seeing it as 10 megs. That's the top part of show interface. So my values are the same. We're going to see if we can fix that. So go back into the interface. We're going to use the bandwidth command. Now the bandwidth command doesn't actually change the speed, the actual speed of the line. It changes how the router looks at, or how the router accounts for the speed. So it's kind of like saying, you can go 65 miles per hour, so that's your real speed, but the police officer who catches you sees a different speed. So if you do bandwidth, this is in kilobits, so we have to be a little careful here. So 100K, 1,000 is equal to 1 meg, 10,000 is equal to 10 megs, and so it's going to be 1 followed by 5 zeros. Now if we show interface, fast01, and now we see this bandwidth has changed. That's what we want it to be. And it's always a good thing to change it on both sides. If you're messing around with bandwidth, go on both sides and change them. So we'll go over to R3. Make sure you go on the right interface. And then bandwidth 1 followed by 5 zeros. All right. Now show IP EIGRP topology on router 1. I may have to clear something out. And we wait a second for everything to catch up. Okay, let's see what's going on here. Feasible distance going to that link 10, 10, 12, so that's the upper link, 281,600. Ten, 10, 23, 0. Okay, that's the other side. 10, 10, 13. 10, 10, 13, 0, that's going to be the bottom link. Feasible distance is 51,200. So 281,600 versus 51,200. So let's draw this down here. I was looking at this one inadvertently, but on this guy, it's 281,000. And this guy is about 52K. So EIGRP is going to prefer the lower one. So it's going to like this link down here. Everything else being equal. Now the thing is, we've just changed the cost only to get to this link. Because we're going on a link by link basis. We just changed the bandwidth on this guy, or not on that guy, we changed the bandwidth over here, and that's it. Let's go on all of our devices and set everything to 100. That way we can get accurate prediction of what we could do. Because if you have the bandwidth set all differently, it's going to get a little confusing. So let's go everywhere. So on R1, fast 00, speed 100, duplex full. Change that bandwidth command. 1 followed by 5 zeros. Go over to R2, and on R2 you're going to have to do both sides. And R3 is going to be the last guy. You're going to be going on fast 00 because you've already changed to fast 01 side. Okay, now with everything changed up, if you go back to R1 and show IP EIGRP topology, your numbers are going to be a lot smaller. You'll see that now both sides should be set at, let's see what we got here. Feasible distance is 28,160. I might have added an extra 0. And the reason I know this is I've done this mistake before where you've set one side, the bandwidth, to be really, really low. So let's take a look. That looks okay. $28,160. Show int fast 00. Let's take a look at what we have. Our bandwidth, that looks pretty good. Delay is 100. Oh, look at that. So on mine, the reason that fast 00 has a much lower metric, 28,000 versus the 50,000, is if you look at the delay, my delay on one side is 100 and the delay on the other side is 1,000. So by default, our metric uses bandwidth and delay. Delay is winning big time on one side. Now, just like the speed, we went on the links and we changed the speed, the bandwidth setting here by typing in bandwidth. Do you think we could probably change the delay the same way? What if we wanted to make these numbers match? Yeah, we can change it. So what I could do, I could go on interface fast 01. And the command is delay. Now here's the problem with this command. I want that number to be 100. It would be very tempting to type in 100. That would be kind of logical, right? If I want the number to be 100, type in 100. But notice what it says here. This is in tens of microseconds. So if I type in 100, and I exit out of there, and I show interface fast 01, you're going to see that my delay is 1,000. And the reason is, for every 1 that you type in there, it's going to multiply it by 10. Okay, does everyone understand that? So this delay statement, whatever number you type in there is going to multiply by 10. You need to remember this because in CCNA, guess what they're going to hit you with? They're going to hit you with a very, very simple problem, and they're going to chuck this in here, and if you forget, you've just missed a question. Also, they like to throw this in on the CCIE tests. You're like, oh, set up EIGRP for 4 points, and you think, oh, I've done this a million times, and you're tired. It's 2 p.m. Very easy to miss this question if you're not thinking. Okay, so if we want the number 100, we probably should type in a 10. So 10 times 10 equals 100. Show interface fast01. And looks good. We have delay of 100. So now if I show IP EIGRP topology, I should get the same numbers. So let's take a look. 10, 10, 12, and 10, 10, 13. Now if we go on our routers, we should be able to ping pretty much everyone. We should be able to ping all 2s. We should be able to ping all 3s. That's the loopbacks on routers 1 and 2. Now if you look over here, you're on router 1, show IP EIGRP topology. This gives you all of the EIGRP routes that are coming in, and then your router makes a decision of what it likes and then chucks them in your routing table. Now here you're looking at loopback 3. This router 3 in the bottom right hand corner, it's a loopback there. FD feasible distance 156,000. So what this means is the total cost to get there is 156,000, and it's telling you that you're going through fast 01. So we're not going to do too much math here, but let's think about this for a second. It costs you, it's a horrible 28, but let's make it a little bit better. Okay, so on the link between R1 and R3, that's 28,000. We know that total distance is about, what was it, 150K. There's a loopback over here. About how much do you think that loopback itself costs? So from R3 going out the loopback, how much do you think that costs? So we know that it's 28K between here and here. We know that it's 150K for the whole length. So what's this guy over here? What do you think that's going to cost? You don't have to type in the exact number, but how would I get that? How would I get that number? What would I subtract from? You got it. Paul's got it right. 150,000 is the total cost. 28,000 gets you from here to here, R1 to R3. So logically, if you think about it, that loopback should cost 150 minus 28. So let's see if that's true. Let's go over to R3. Show IP EIGRP topology. look up the entry for 3.3.3.3. It's connected loopback 0. Feasible distance, the cost to get there, 128,000. So 128,000 plus the 28,000, about 156,000. So it's very simple. To get the total cost from one side to other, you just go on each link and add in the distances, add in the metrics. Extremely simple. Now, that 128,000, if you look and you go back to R1, we have this second number in this bracket here. The first bracket, or the first number in the bracket, is your total distance. So we know the total distance to get across is 156,000. This guy right here is the distance that your neighbor knows about. So this is how far your neighbor is telling you. So your neighbor is saying it costs me 128,000 to get there. So router 3 is telling R1, by the way, I can get there and it cost me 128K to get there. So our top link is 100 megs, our bottom link is 100 megs. We're going through the bottom link. If I were to make the speed of the link from R1 to R3 really slow, so let's say instead of 100 megs, I suddenly change this guy to 1 meg. What possibly could happen to my traffic going to that loopback? Would it stall or would it go a different way? Okay, some people say stall, yeah, reroute, yeah. So because I'm making this guy really, really slow, if everything's working correctly, we should get this to reroute the other way. So let's try that. Let's go on R1. Go on the right interface, interface fast01. Bandwidth 1. And this isn't 1 meg, this is 1K. You've just completely told the router this is a piece of crap prehistoric link. And so now if you show IP EIGRP topology, take a look at this. Okay, this is the path information. Now on mine, I got lucky. I got an A here. See that A? We don't want A. We want P for passive. And actually we had a CCNA, a member who failed his CCNA test. And one of the problems he had was reading this table. He didn't understand that P was actually good. He thought that P meant this is bad. And so he spent a lot of time troubleshooting when everything was working fine. So the A means active. Your router is trying to find a better path to that loopback. And P means, okay, I've finally figured it out. So let's take a look. If I'm going through the bottom link, it's going to give me a ginormous cost, whatever that is, right? An insane number. If I go through the top link through router 2, the number's much smaller. Now what you always want to verify is you want to show IP route. And your show IP route will show you that to get to 3.3.3.3, I am now going through 10.10.12.2, which is the top. And we can verify that. Trace 10.10.12.2. Or actually, the trace should be going to all threes. Now this trace route is probably going to be a little inaccurate because traffic going one way is probably going to take router 2. Now traffic coming back is going to take a different stance. So we see that it's going router 2 and router 3. So that's good. We're okay. From router 3's perspective, if you show IP EIGRP topology, getting back to router 1, you can see right here, my top link there under 1.1.1.1, if we're going to the loop back, I'm going through router 1, so that's that bottom link. If I'm going to 10.10.12.1, then they're both equidistant. So it might go through the top or it might go through the bottom. So the traffic doesn't necessarily come back the same way. So if you ping through the top, we're not guaranteed that the traffic returns through the top. In most instances, this is okay. This is not a big deal. In the CCNA world and the CCNP world, we're not that concerned about having traffic go certain ways. If you send through the top, that it has to return through the top. When you get up to the CCIE level, that's when we kind of specify a lot of that stuff. Was everyone able to get your traffic to switch from the bottom link and go through the top link? That was just changing the speed, the bandwidth of the link on the bottom. Should be a very simple process. You make one link really, really slow, and then you change. Okay, great. We're able to get links into EIGRP. We're able to get neighbors up. So we've been throwing all of our links into EIGRP using the network all zeros command. That's a horrible, horrible way of doing it. So what we're going to do is we're going to go back to R1. We're going to nuke EIGRP, and we're going to redo it the correct way. So no router EIGRP1. Right, everything goes down. Network goes nuts. Router EIGRP1. No auto. And before we type in the network command, you want to get into a habit of showing what your interfaces are. So you have a list of IP addresses right in front of you. This way it makes it easy. Save the brain cells. So network command. If I just want to throw the loop back in there, an exact match would be 1111 and then 0000. It's a wildcard mask. You can see nothing really comes after that. And if I want to throw fast 00, it's 10.10.12.1, the exact IP, and all zeros. And do the same thing for fast 01. Right? So here we're manually typing in these three interfaces, the IP addresses and the wildcard mask, to basically say only throw in 1111, only throw in 10.10.12.1, and 10.10.13.1. We're being a little bit more exact, or much more exact. And we'll end out of there. We'll do our gut check, show IP EIGRP topology. We have EIGRP routes coming in, show IP EIGRP interfaces is always good. So everything seems to be running like normal. Okay, now if you show IP protocols, you'll see down here EIGRP metric weights. So remember I told you guys that normally EIGRP uses bandwidth and delay when it calculates the metric. You have 5 K values, and if you read your book, there's that big formula. But K1 is the bandwidth, K3 is the delay. So 1, 0, 1, 0, 0. Whenever you see that, you know that, okay, it's using bandwidth and delay. Now the metric weights have to match on the routers for them to come up. And just to show you what I mean, if we go on router 1, let's say, we can change the metric weights by going into EIGRP, so router EIGRP 1. The command's very easy. Metric weights. You do a question mark. Now here's where it's kind of weird. You just can't type in the 5 numbers. You know, K1, K2, K3, K4, K5. It doesn't work that way. You have to start off with a 0. And the reason is you just do. Maybe they were planning on doing something with this type of service. Now by default, your router, you can think of it as it typed in this. So 0, 101, 00. But let's change that second one. Let's change it to a 5. So we're going to count bandwidth 5 times more. K3 is delay. So you change that K1 value, which is the second number in there, change it from a 1 to a 5 or an 8 or a 10 or whatever. And you'll see that you have something called KValue Mismatch. So this simply means that the other side wants something, your side is saying something else, they're not matching, so the links are not coming up. This type of problem is pretty easy to diagnose because you can see it right on your screen. It tells you exactly what's happening. Can anyone think of a situation where you have a k-value mismatch like we have here, but you won't be seeing any of this information? Because this is too easy. If you see this, you know exactly what's happening. Logging turned off. Maybe you're logging to somewhere else. So let's see if we can change that. So logging. So let's see what happens if we do no logging console. Quiet. Nothing coming up. No logging console. And you can see things have stopped. And if you show log, nothing's there. So we've just pretty much owned ourselves because we're not logging to the console. We're not logging to the buffer. Stuff's happening, things are dropping, and your logs wouldn't say anything. You would have no warning. Now if we turn on logging to the buffer, at least we can see by showing log that something's happening. So you got the console logging, which is what you see in front of you. As soon as it scrolls past, you miss it. And then you have your buffer logs, which keep a kind of like a running count, a running tally of what's happening. So kind of like your event viewer in Microsoft. So you do logging, buffered, and we'll say we'll give you 100K for the log. Now if we show log, our error messages are now going in there. So this type of stuff is something that you might see, let's say in the CCNA exam, because they're throwing a lot of troubleshooting in there. So it's a k-value mismatch, and to throw the curveball at you, logging is turned off. What I would do if you're having EIGRP problems is if your interfaces are up, you go on the router, show IP EIGRP interfaces, you see interfaces, show IP EIGRP neighbor. Right? If you don't see anything, something's wrong. Then what you should do is show IP protocols, and just to make your life a little easier, pipe I, K, and you'll just get the line with the metric weights. So you'd paste this line into all of your routers. If you get different K values, you've found the problem. Because I don't know about you, but if you're tired and you show run, you might miss it, right? Because a lot of you have a tendency like space, 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 and you're like, whoa, yeah, what's going on here, right? I guess what you could do, you could show run pipe I logging just to see if the logging's been turned off, right? No logging console, that's kind of a hint. Okay, so let's turn this back. So back into router EIGRP. Metric weights 0101. Show IP EIGRP neighbor, and my neighbors are back. Okay, so basic EIGRP, not a problem. Now let's go back to our diagram here. So let's say on R2, you've got your connection out to the internet. You want to tell the rest of your network, hey, come to me if you have any traffic that's not known by anyone else in the network. So basically, if you want to go to Google, go to me. If you want to go to YouTube, come to me. EIGRP works a little bit differently than OSPF. We've got this command in EIGRP called summary address. So we can send a summary out. And this summary can be all zeros, which basically says everything. And we can send it out both sides. And now the reason we want to send it out both sides is first, I'm going to show you what happens if we set it up just to send all zeros out the left side. Now before we do this, who can predict what's going to happen if I send out an all zeros route from R2 to R1? And let's say anyone on our network wants to go to YouTube. How's the traffic going to go? Okay, so if R2 sends out a default route, an all zeros route, just out the left side, look at it from the perspective of R1. R1's going to have a routing table. One of those entries will be for 0, 0, 0, 0. It's going to have a next hop of 10, 10, 12, 2, which is router 2. So it's going to want to send traffic that way. R1 is going to send this route to R3. R3 is going to have a table, all zeros route. His next hop is going to be 10, 10, 13, 1. So R3 is going to want to send the majority of his traffic to R1. So anyone connected to R3, say we have a bunch of links there, they want to go to YouTube. Well, it's as if this line doesn't exist. So let's check it out. Let's see what happens. First of all, we need to go to R2 and we want to have an exact match for all those interfaces because I want to make another loop back with a bunch of IP addresses to represent YouTube or Google. And the reason we have to do that is it's kind of dangerous because if I show run pipe B for begin, you'll see that we use this all zeros command. And so that means whatever loopback I add in there, it's automatically going to be chucked into EIGRP. That's not exactly what we want. So conft router EIGRP1 do show IP interface brief just to give me a reference of all my interfaces. And then do no network all zeros. So take out that Hail Mary route. Everything goes down as we predicted. And then just add in everything exactly. And finally the loopback. Show IP EIGRP neighbor, and you should see your neighbors. So we've added in this stuff exact match. Now we're going to make a loopback, interface loopback 888, or whatever, it doesn't matter what number you use. Give it an IP address 8888. So now you have this address. You can ping it from router 2. And because you're not throwing it into EIGRP, no one else knows about it. Right? So you just do a quick gut check, show IP EIGRP interfaces. You should not see loopback 888 in your EIGRP interfaces table. Now we're going to go on the interface pointing towards R1, that's fast01. We're going to chuck out a route. We're going to use the summary address command. And basically this is saying, hey, if you want to go to 0000, which is pretty much anything that you don't know about, then you're going to come through this interface, fast00. Now before we do this, we're going to go on R1, debug IP routing. We want to see changes in our routing table. Then we go back to R2, IP, summary address, EIGRP 1. Now notice here it's asking for your autonomous system number. Very easy to screw this up. You're used to typing in 100, this one wants 1, boom, you got the question wrong. So a lot of times troubleshooting with EIGRP comes down to wrong AS number, wrong metrics, just a number is mistyped. Very, very easy to do. So IP summary address EIGRP 1, and then what IP address do we want to send out? What route do we want to send out? So we're just going to say, hey, default route. All zeros. So you're checking out all zeros over to R1. Show log. Oh yeah, because we disabled our console logging, so we have to do show log. This is going to go on for a while. There we go. Okay, let's see what we got here. Let's see, we had some network craziness. Deleted to the loopback for router 3. We added it back, that's fine. And we added all zeros route. That's cool. Default network, so we're going through there. Sounds pretty awesome. 0000. So a all zeros route was added in there. Now because my log has a bunch of crap in it, let's clear the log on R1. Clear log. Enter. And let's make it so our logs don't have all this time step information. So this March 1st and all that crap. So conf t, no service. Timestamps. Okay, so we got an all zeros route in our routing table. So if we show IP route, you'll see that we have an EIGRP route, all zeros, coming from router 2. Let's go over to router 3. Show IP route. All zeros route. 13.1. So it's telling me to hit router 1. So watch this. Ping 8888. I get a success, so that's good. Let's trace 8888. Oh, would help if I trace the right IP. Any day now. So let's go into router 1 and then router 2. Router 1, router 2. This way. Does everyone understand why it's going router 3, router 1, router 2? So what if we wanted to force traffic going to 8888? If we wanted to force traffic to go through the 2 to 3 link, so router 2 to 3. So if we wanted traffic to actually head out this way for all 8s. Now since we're in EIGRP, we could do a summary route going out this way. That is an option. Now for those of you guys going for a CCIE, you want to think all options. We could do a static route if they allow us. We could put a routing protocol in there with a lower administrative distance. That actually might be tough since we're talking about EIGRP, but we could change the administrative distance. That might be a little bit better. But there's lots of ways we could do this. But for now, let's see what happens if we throw in a summary route, another summary route from R2 to R3, and then we'll finish up. So go on R2. Interface fast01. And you've typed in the summary route before, so you could just hit the up arrow a couple times. It'll say IP summary route EIGRP1. Hit enter. And let's see what happens on R3. R3, we get some stuff here. Hit the up arrow a couple times until you get back to show IP route. And now you have the summary route, all zeros, 23.2. So that's going through the upper right link. So now if I trace route to 8888 from router 3, I'll go through the closest link. (23.2). Now the cool part about this is we have a little bit of redundancy. What do you think is going to happen if the link between 2 and 3 dies? What's going to happen to the traffic going to Google? We could start a ping 8888, repeat 10,000, let's say. Okay, so we have pings. They're going from 3 to 2. Life is good. We go over to R2, go into interface fast01 and shut that side. So some of my pings could fail, and they are. They're dying. And we twiddle our thumbs. The neighbor goes down. Hold time expired. It switched over to R1. The route became active, and now the pings are going through the other way. Now, how many of you think this delay would have been noticed? Wasn't necessarily that long. It was about 15 to 20 seconds. Now we're going to change the times that it takes to converge, and that's going to be our last thing for today. What we want is, if the network breaks down, we want this convergence to happen a lot quicker. Okay? Because this is pretty unacceptable, having a 15-second wait. So let's go back to R2 and no shut that guy. No shut. And so let's do this. We're staying in the interface. IP hello interval, EIGRP 1. We're going to make this every second. And we're going to change the hold time for EIGRP 1 to every 3 seconds. So if I don't see something in 3 seconds, I'm going to consider it down. We're going to do this to both sides. So IP hello interval, EIGRP 1, 1 second. IP hold interval, EIGRP 1, 3. Be very, very careful with this command. How many of you think it would be really, really easy to miss this command? Like they could put in EIGRP 1 and not, kind of forget that second one. If you're given a list of which one of these commands is correct or incorrect. You've been staring at the exam for 70 minutes. You're getting down to the wire. It could be very, very easy to miss. So it's IP hello interval, EIGRP 1, it's the autonomous system, and then the seconds. Okay, so theoretically, we'll miss 3 seconds of hellos, and then we should switch over. And this should be a lot faster than the 15 to 20 seconds that we did before. So ping 8888, repeat 10,000. So we have pings going. Go back to R1, shut that sucker down. Shut down. We've missed 1 ping, 2 pings. Boom, we're back up. So somewhere between 2 and 3 pings, we're back up. If you're running any router that's been built, or not any router, but any Cisco router that's been built in the last 10 years, tune your EIGRP timers. Just, don't be stuck with the 5-second hellos. It's just horrible. Unless you're dealing with WAN links and 3G and all that stuff, then don't do it. Satellite links also. Any problems with getting the link to come back up in about 3 seconds? Any questions about the topics we covered today? And we've got the chat window, should be on the right side of your screen. I think some of you have your chat set to private, so at the bottom where it says send to, you probably have my name selected instead of everyone. Okay, and what do you think about the WebEx? Thumbs up, thumbs down, same as Google Hangouts? Is anyone watching this from an iPad or an Android device? Or is anyone watching this on a Mac? Windows 7. Any Windows 8 users? Windows 8. Crappy Windows 8. Okay, we're going to end it here. Thankfully, this was recorded with both Camtasia and the built-in WebEx recording. I'm going to put both links up so you make determination of which one you like. 100% that the YouTube Camtasia one will be insanely better quality, but we'll just see how close the WebEx recording comes to. I believe the WebEx version, you could put in markers where you could click and it'll jump to certain sections, but I don't know if that's automatic or if to manually hit certain buttons while I'm doing the recording. So we'll make a decision on that. If you have any other comments, feel free to email me or email the list. We're just checking out the WebEx. I think it's okay for the beginners. Let's see how many people we have in the room. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And when we started, we had somewhere around 15. So we definitely would have filled up the Google Hangouts room with that, which has a maximum of 10. So I think this will be okay. Okay, we're out of here. This is Beginners EIGRP 1, and part 2 will be next week.